Okay, this is question 3 from June 2005 paper A2 paper 3, which is the physics 6 module on particle physics, and this question is about antimatter and antiparticles. So first question just basically asks what is antimatter. There's a little bit in the question before that goes on about the Starship Enterprise, but it's essentially asking what is antimatter. So antimatter is matter consisting of antiparticles, which are particles with the same mass but have a different or opposite, the same mass but an opposite charge. And that's what an antiparticle is. It is the same mass as the particle but has a different charge, an opposite particle. So antimatter is just matter which consists of those antiparticles, that is, particles which are the same mass but an opposite charge. Then the most commonly observed matter-antimatter interaction is that for annihilation. And that annihilation reaction is an electron and a positron. When they meet, they produce gamma ray photons. Okay, so electron and a positron, this again is a very common question. Annihilation and gamma ray photons, so 2 gamma photons. Now it says, making reference to a relevant conservation, explain why an even number of photons must be produced in the electron-positron interactions. Okay, so here the conservation law that we're going to talk about is conservation of momentum. Now this is very important in terms of this, that we understand what's happening here. So whenever whenever 2 antiparticles meet, so whenever the positron and the electron meet, before they meet, they are traveling in this opposite directions towards each other, and they carry momentum. The total momentum that they have before must be 0 because they have the same mass traveling at the same speed. That means that in order to conserve momentum, they must produce 2 photons which are carrying equal quantities of momentum in the opposite direction. And that's essentially the answer that we need to give here. So that before the collision, the total momentum is 0. Now, and that is because we have 2 particles the same speed traveling in opposite directions. So before the collision, the total momentum is 0. After the collision, the momentum must be 0. So we must produce 2 photons with equal but opposite momentum. So 1 photon moves to the left, 1 photon moves to the right. Same speed, same mass, same momentum, but in opposite directions. Therefore momentum is still conserved. It's still 0 after. One other conservation law that must apply, well, we have conservation of momentum was what we had above there, so conservation of charge must apply, and conservation, so we must now conservation of charge, and I'm sure that they would accept conservation of energy, but remember that would be energy or mass energy according to Einstein, where those are equivalent. So, but definitely conservation of charge is always conserved in those interactions. And that's the end of that short question.